Let's solve the numerical on heat transfer through a hollow cylinder. Let's assume you have a cylinder used to pass the steam, and steam temperature is 350 degrees centigrade. This cylinder is made of steel, and to reduce the heat loss, 3 centimeter thick fiberglass insulation over this SS cylinder have been done. And if inside diameter of the cylinder, steel cylinder is 12 centimeter, outside diameter is 20 centimeter, and the outside layer temperature of this particular layer temperature is 60 degrees centigrade, in that case we need to calculate how much amount of heat loss will occur. So let's solve this problem. So as inside diameter is 12 centimeter, so R1 is equal to ID by 2, or ID is inside diameter is 12 centimeter by 2 is equal to 6 centimeter. Okay, or you can convert into the meter, is equal to 0.06 meter. Then R2, outside diameter is known to you, so outside diameter by 2 is 20 by 2 is 10 centimeter, or you can say 0.1 meter. R3, so R3 is equal to R2 plus thickness of insulation, thickness of insulation. So what is R2? R2 is 10 centimeter plus thickness of insulation is 3. This is 13 centimeter, or you can say 0.13 meter. Then inside temperature is known to you, that is T1, 350 degree. T2 is not known to you, and T3, the outside temperature is 60 degrees centigrade. And the thermal conductivity of K steel is equal to 48 watt per meter per Kelvin, and K fiberglass is equal to 0.032 watt per meter per Kelvin. In that case, we need to calculate how much amount of heat loss will occur, and secondary, what will be the temperature of interface, that means T2. Okay, then let's write the equation for heat transfer through this hollow cylinder. So Q is equal to 2 pi L T1 minus T3 by ln R2 by R1 by K1 plus ln R3 by R2 by K2. So here this is a K1, this is K2. Okay, so now solve this. 2 into pi 3.14. Length of this cylinder is known to us as 75 meter. So let's write 75. Inside wall temperature is known to you. This is 350 minus outside temperature is 60 by ln R2 by R. What is R2? R2 is, either you can write 10 centimeter or 0.1 meter, but R1 and R2 unit must be same. So I'm using centimeter. So ln 10 by 6 by K1 48 plus ln 13 by 10 by 0.032. Solve this one. You'll get 136590. Okay. 0.01 plus 8.125 is equal to 16790.4, or you can say 1.6790 for 4 watt. So this much amount of heat will transfer. We need to calculate the interface temperature, that is T2. To calculate the interface temperature, you need to write the equation for any one of the section. Any means either you may write the equation for the steel or you may write the equation for fiberglass. So I am writing the equation for the steel section. So equation is Q is equal to 2 pi K1L by ln R2 by R1, and this is T1 minus T2. So let's rearrange the equation a little bit because we did some calculation in the previous equation. So now it's 2 pi L T1 minus T2 by ln R2 by R1 by K1. So this we know. So what is the value of Q here? Q is 1.679 into 10 to the power 4 is equal to 3.14 value of pi. 75 is the length. T1, we know the value of T1 is 350, but T2 is unknown to you. Why? This we have already calculated, and this is the value, and final value is this. We'll directly write 0.01. So if you'll simplify it, you'll get T2 is equal to 350 minus 0.3565. So T2 is equal to 349.64 degrees centigrade. So very less difference between T1 and T2. So if you will not do the insulation, higher amount of heat loss will occur.